Okay. So what I want to do, as much as we can, I would love, since hopefully you watched yesterday, we did a couple of these yesterday. There they are, 5 and 6. I want to finish this up today. I want to get classwork 3.1 done and submitted today. Okay, it is due today, 1 through 8. 1 through 8, all of them. We've done this now a week and a half straight, and we're starting to kind of get the hang of it. And I know in yesterday's class, it was really nice to talk these through. Not necessarily doing them on our own, still doing it all together, but just kind of going through this process of, okay, how do I make the table again, and how do I make the inverse, and then how do I graph it? I kind of seeing it in action and not necessarily trying to really do it on your own. I think really kind of set, and you guys at home, you can let me know if this is true, really kind of set it in stone for you to feel a lot better about how to get these done. So, so here's what I'm going to do. I'm going to leave this up. This is from yesterday. If you did not do this yesterday, take a picture of this right now so you can do it later. I saw you, Jackson. That was a good idea. I like that. Okay, because I'm going to erase it so we can do 7 and 8. Now, we did 7, quote unquote, on Friday, but after a snow day, I have a feeling that I think it would be good if we just did 7. It seems like a lot, but as we work through it, it's really not such a terribly difficult concept once you get the hang of it. And the thing that I think is making this really easy for a lot of people is someone had a really good idea to find that calculator app, and I think Paige is the one that actually, I forget who found it, but there's an app called Calculate 84. If you don't have a physical graphing calculator, you need to download this right now. It is incredible. It's not exactly everything that the calculator can do, but man, it is everything we'll ever hopefully need it to do. I have one thing that I want to look for the stuff we're going to do after spring break. I'm hoping that that's on there because that'll make our chapter 4 live. So, all one word, Calculate 84. Really, really nice graphing calculator app. Desmos is great, but it doesn't give us really nice tables. And I don't know. There's more that I like about this than any other app that I've found so far. So I'm a big proponent of it. It's free. Doesn't take a lot of data. Doesn't take a lot of space on your phone. So it's pretty simple, but really useful. Okay. Yeah. Stay put. I'm going to do it for you. Anybody else need a copy? Are we good? Classwork 3.1? Okay. I'm going to erase all this. Let's do 7 and 8. Folks at home, here's the deal. You know what you're doing? Go do it. You don't have to stick around, but it is due today before midnight. Okay? Classwork 3.1, all of them, 1 through 8. We've done all of them together, including the 2 that we're about to do right now. So if you want to stick around, I will do those 2 with you, and then you can just get it. I'm going to erase some of these things, but keep up other things like that. All we really have. But I know it's been a while since you guys, cohort B, you've actually sat in class and done this all together. So that's why I want to do it with you. Because what I'm thinking is that, all right, cool, 3.1 today, get that done. I'm going to give you 3.2 that will start tomorrow, which is just more practice, the same thing, but you'll have some freedom to kind of do it without me rather than quite so much with me.
Hey, Rosie.
What's up?
So I got quarantined because my sister got sick. So I'll be online for the next 2 weeks.
Okay. Everything will be on Canvas for you.
Okay, and then will the document too, so I can print that out.
Yeah, I'm gonna put 3.2 up really soon. 3.1 should already be on Canvas. 3.2, because I'm giving it out today, I was gonna put it up later today.
Okay, sweet. Thank you.
But if you want it, here, you know what? Super quick. I have it open on my computer. Let me just I'll just share it with you right now. I'll put it in the chat.
All right, thank you.
You got it, Bill.
Rosengren, you got me for attendance, right?
If you are here right now, you will be marked present.
Okay, thank you.
Thanks, Dal. So there's 3.2 right there in the chat in case anybody wants to get a jump on it. But we're going to do 3.1. We're going to finish it up. Let's go all the way to the back, number 7 and 8. Let's knock it out. Okay. Had a really nice back. There we go. But I'm going to rely heavily on the calculator to get us started for sure. Y equals x plus 2 cubed plus. Now I know I didn't write the instructions. Let me turn the camera so we're facing. There you go. I know I didn't write the instructions on this. You'll see the instructions once you get to 3.2. But the idea are those 4 things in red over there. And I think it's like kind of goes just from like easy to difficult. So why not start with the easy stuff? Let's make a table of points that are going to actually fit on our graph. And the thing about the graph that's given to us that I really like is the x's go from -10 to 10 and so do the y's. And so really all I'm looking for is a way to figure out like, all right, cool. This is my whole crazy looking function. Whatever it is, what are some of the nice ones? I don't want decimals, I don't want fractions, but I also don't want numbers that are too big because they're just not going to fit. And so that is where I jump into my calculator, I give it the equation, and I start searching for some points. So in a calculator or on your phones, go to y equals. I'm going to do it here. I'm just going to turn it towards you. Okay, so top left-hand button, y. Type in exactly that function. Parentheses, the x is the one next to the alpha, okay? Just to the right of the alpha. X plus 2. Now, close parentheses, and it's like, oh, well, how do I do an exponent of 3? Because there's no button for x cubed necessarily. That is where, above the division sign, you see that kind of like up arrow, kind of they call it a caret. You press that button, it moves you up into the exponent. All right, so you press that up arrow above the division sign, it'll start kind of blinking in the exponent, and then you can just type the number 3. But when you do that, you're still in the exponent. And if I want to do a +1, I can't just type +1 because it's going to like just add 1 to my exponent and make it a 4. You have to right arrow out of the exponent. You press the right arrow, that kind of gets you back down into the space you want to be in, and then a +1. Okay, so your y equals should look exactly like it's written right here, which is really nice. That's why I like this calculator app. That's why I love the graphing calculator. Some of the older calculators will actually just draw the up arrow caret and you don't have to worry about it. Now, I want to make sure that the table that I get is set up correctly. And so there's a way that we can actually set this up ahead of time so that we're not messing with it once we actually get to the table. That's why I wrote it down over here. Start by going to TBL set, which is second window. All of the buttons at the top of your calculator are all graphing buttons. And TBL set, since it's in blue or yellow or green, whatever color they choose, it's above the window button. You have to press the second button first and then press it. And what I want is I want these two things to be exactly this. I want my table, to start at -10 because that's where my graph starts over there on the left. And so if your table said it says anything except -10, then actually type in -10. Now you want to be careful. There's a negative button and a minus button. Okay, the negative button is the one below the 3. That's the negative next to the decimal. That's the one you want to press right now. Subtraction is the one next to the 6. We don't want to use that one unless we're actually subtracting. So it's not at -10. Your delta table, how much your table is going to change by, is reset to 1, and we like that. I like that. Because that'll just go -10, -9, -8, -7, and we're good to go. And then I actually want to look at the table, which is second to that. So I press second graph, which is table. And I look, and my goodness, yeah, my x values are nice, but my y values are humongous. Humongously negative, but still humongous. And I don't like any of that. I can't fit any of those. So I'm not going to write them down. If I cannot fit them on the graph that they gave me, why am I going to write them in the table? -10, -9, -8, none of those are good until we get to -4, -7. Right? Because -5, -26 does not fit on my graph, so I'm not going to write it down. But -4, -7 fits. -3, 0 fits. -2, 1, -1, 2, and 0, 9. Now I'm still going to like press the down arrow a bunch of times just to check to see if anything after 0 looks good. But oh no, 128, 265, 3, 126. Now these numbers are just going to get bigger and bigger. So I am done. So when I ask you to make an XY table, it's just, do I know how to let the calculator do all the work for me? So I'm not actually like plugging in numbers myself and seeing what happens. You know how to do that? You're off to a really good start. Questions about that? We good with that process? If you can do that yourself, this next week and a half is going to get a whole lot easier. Because that's what we're going to do. We're just going to focus on inverses until spring break, rather than starting something new, going on break, and then we probably just having to start it all over again. That'll just make your lives a little easier, kind of leading up to the end of the third quarter, which is crazy. My goodness, the end of the third quarter is next week. And then you can just break over spring break. Cool. So there's our XY table. Part 1 done. Nice. Make the table. Now, let's make the table for our inverse. That's all we're doing. We're just looking at inverse functions. But when I put that table side by side, I feel like, okay, I know how many numbers I had for my first table, so I feel really good about how big to make my second table. These are just going to be the same. But even before I put the numbers in, I know it's been a while, but there's something missing in that inverse table. Beautiful. Above the y, kind of in the exponent space, that little -1, because that's inverse notation. And now I know exactly what table I'm looking at. I'm looking at a table 2. Sweet. How do we make it? So it always comes back to, all I have to do is take all of my y values and drop them into the exponent. -7, 0, 1, 2, 9, -4, -3, -2, -1. There we go. I'm going to get you a couple things. Rulers so we can draw straight lines. Now this is cubic. It's not actually going to be straight, but the line that splits them down the middle will be. Other thing that if you want, you can take out a second color, or you can borrow a colored pencil from me. Nice. Edge your ID is a great straight edge, especially on small graphs. The thing that I like about having a secondary color, especially if I'm graphing them both at the same time, I know which one it is. You don't have to. So if your answer is no thank you, I'm cool with that. But if you want one, here's one. Cool. And here's the key. Graph the first one, but don't connect them yet until you actually press graph on your calculator so you can look at it. What I find to be really helpful is letting the graphing calculator do its thing and show me. I don't know how sharp that is. Does that work for you? On the gray and black table. That's not right.
Oh, yeah.
Because as much as I want this graph to like be easy to graph, it might not be as easy as you think. Now I'll go back here just so you can see it in action. I graph this thing. And down. So neat, God, using that. I literally dropped my water bottle and a puddle of mud. The hard part about graphing some of these is like if you plot the points, you're just not sure what it's supposed to be. And that's where the graphic calculator plays a role. Because when I come over here and I'm like, all right, cool, let me put a point at -4, -7, -3, 0, -2, 1, -1, 2. Like those three kind of look like they should be in a straight line. They are not. They are definitely not. When you look at the graph, you will see that the way to connect them is you like cross through that point, you keep going like up, and then you slow down, bend, turn, and then up. You're not gonna know that unless you actually press the graph button and take it. Qubits are functions like that. Just because a lot's happening around that number, numbers are changing very slowly. Now, only 5 points, sweet. But this graph obviously keeps going because we skipped a lot of numbers from our table. So make sure that you extend it, put an arrow on the end. Just make sure you don't cross that next grid line. Extend it, throw an arrow on the end, make sure you don't cross that next grid. And the order that you graph your points in is the order that you wrote them down. So just make sure that you have that bend around those 3 points. And the qubits are always the same like that, which is really nice. They're always going to have, it's actually called flexing. Literally, like that's the mathematically technical term for it. Flexing. Anybody taking college algebra next year, you're going to do that. So there's your little thing. We're going to graph polynomials. Right? Now we can graph our inverse. Here's where I just switch colors. That's just a choice I like to make. Did I do it yet? Yeah, I'm in blue. But I plot them in that order and I connect them in that order. Okay, so -7, -4, 0. So 0 is the x. So I just don't go left or right. I go down to -3. So be careful not to put that at like -3, 0, but at 0, negative. 1, -2, 2, -1. And 9. This one's just a little bit trickier because when you aim for that one at 0, -3, again, you keep going and then you flex up and then you flex out. It's called the inverse for the reason. It's the opposite. Whatever you did, do the opposite. And again, I cannot worry about you being perfect. I just want your best, right? We got more points, so let's extend it out. Don't cross that next grid line. Extend it out. Don't cross that next grid line. Draw your arrow. Good. Step 1 done. Make a table. Step 2, make the table for the inverse. Step 3, sketch your graphs. But we always want to include the line of symmetry. Do you remember where that goes? Do that again, Bree. I liked it. Perfect. Top right to bottom left. Okay, and I'll just dash it. It's a straight line, so use the straight edge that I gave you, or use the edge of something straight. You know, edge of a folder, an ID card, something. It's a pretty small graph, so you're good. But I just love having that line there because then I can turn the thing sideways, put that line perfectly vertical, and I see the symmetry. Stare at it, and I'm going to follow this. Brains love it. Makes sense. I like that. The algebra behind the scenes is a little bit more technical, but we want to do that too, so we'll do that one last. Let's find the inverse. Cool. And that's this process over here. Pick this up from last week. Hoping that it will be helpful just to see again so that we can use it. Okay, very cool. So if it's not y equals x, we'll write that way. Right? If it was f of x and b of x, and you'll see that on classwork 2.2, I'll start writing with the function of basis just so that we can make that quick. But of course, what are we going to do? Switch x and y. I'm gonna stick with the black. Usually I change colors from one step to the next. The black shows up really nice with the that. Literally just swap them. The X becomes Y and Y becomes. And like that, that's the inverse. That could be like, you go to decimals and you type both of those equations in, it's gonna get you that graph. Done. Because decimals can read it that way. But we can't. I need a y equals equation to actually see what the inverse is. We have to go solve it. We have to get y by itself. And that's where all of the work is going to happen. Now that y is kind of stuck inside there, now it's time to start moving some stuff around. And how do we do it? We solve it the way we always have. The way we always will. Solve equations by undoing what's happening to what we're trying to get alone by doing the opposite. Starting with the simple one. So here it is. That's what I want alone. So I got to get all this stuff over here. The right side gets simpler. Left side is just going to get more complicated. We're not going to simplify. We're just going to bring it over and do it up. So what do you think we should do first? Try to get this typed up. What can we move over? Let's do -1, -1, -1. Like I said, right side gets simpler, right? The +1, the -1 cancel out. So I'm just left on the right side with that, the y plus 2. Parentheses around it, cube goes on the outside. And however you would read the left side out loud, like vertically, is how we're just going to write it horizontally. X -1, okay, cool. X -1. Don't drive yourself crazy trying to like make things simpler and put stuff together. Just bring the numbers over and let it get complicated on that left hand side. Now, if there was a number right after that equal sign that was being multiplied through, now would be a great time to divide it. But it's just a one. So we're good. We don't have to worry about doing anything in this step. Sometimes we have a decimal effect and sometimes we don't. Sometimes we have multiplication, sometimes we don't. Now we're ready for that. We've got one, so we got to get rid of it. Now, when it was like something squared, the opposite of that was a square root. Because those go together. This is not y plus 2 squared. This is y plus 2. So the opposite of squaring something is a square root. What's the opposite of cubing something? Cube root. That's what I'm going to do on both sides. I'm going to take the cube root. I put in a little radical, but I'm going to put a little 3 in that little nook right there for and just like a square and a square root cancel each other out, a cube and a cube root cancel each other out, and that's the whole point. That's the only reason I did it is because the right side we do. And we can even drop the parentheses there too, because the only thing that was on the outside was the 3, and now that part's gone. And again, don't try to go crazy simplifying whatever you just did, just write it. Plus and minus is only for even roots. Square roots, fourth roots, sixth roots, and so on. Breathe an odd number, so like that. Exponent root is done. Now I'm finally inside the parentheses, inside that grouping symbol, but I don't have them anymore. Now we're good to go a little -2, a little minus. The order that you decide to write this last step of work in is up to you. You can write it exactly as you would read it. Just make sure that your cube root ends before you put -2. In other words, leave some space after your cube. Do this. That -2 was not part of a cube root, cannot be included. That's a great answer. Some people prefer to have the cube root at the end rather than the beginning. That's good. Did we do it? Yeah, we got y equals. It's just on the right side rather than the left. So I know that bothers me, might not bother you. I usually like make this switch and call it y equals. And you can just copy this down exactly as it is. Or you can say, oh, I've got a nice minus 2. Geez, what do I put in front of this? This is obviously negative, so I'm just going to bring that minus with it. But like, is this cube really? Should I put a plus? Should I put a minus? Should I just multiply? What am I supposed to do? Well, let me ask you this. Is that number positive or negative? I don't need a plus sign, do I? Is this cube root positive or negative? I don't need a plus sign, right? Not here. But if this was, like 5 minus x or something, if I wanted to switch that around, that would be negative x plus 5. Sign for the x equals sign for the 5, the same thing. If you want. And I think that might just be an opportunity to make a mistake, so I am totally cool with the line right above it. If you want to do it well, that's better. I'm good with that. So do what works for you. Do not create opportunities to make mistakes at these points. You've got a good version. But there's still one thing missing. We're done. We made it. That's the inverse. We need it whether you're doing it here or here. Absolutely. Okay, I don't care which one you pick. Pick one. But either way, once you get y by itself, you got to use that inverse function notation. Coming back to you a little bit. Now you see it again. Sweet, let's do one more. And then I have done every single one with you. Right? If you have them written down or not, that's up to you. That was number 7. Let's do number 8. It's going to be the same thing. I just wanted to do this one again. It's just a little bit funky looking, so I wanted to show you what happened. Mostly specifically in a calculator. We got some stuff that happened. I just want to show you. This really kind of covers everything. Y equals again, so we're not putting any changes, that's good. 2 square root of x plus 8 and the square root. I mean, you don't have to write it again. I had it. Let's do it. Make an XY table. Here's one. Ball in the So I'm going back to my calculator. I'm going to y equals, so I can type it in. But I still have that equation, that cubic from number 7, still stuck in it. What's the fastest way to get rid of all that stuff in it? Clear. If you press delete, you're going to lose one letter or number or symbol at a time. Clear is going to get rid of all of it all at once, and you type it. So 2 first. Where's the square root? It's on the front. It's a little harder to find. You don't have to search for it in folder. There's the square root of it. Oh, it's above good. Second x squared. So after you write your 2 for the number in front, that's not a square root 2. That's why it's nice and big. If that was a little square root, it would be like a little tiny. You wouldn't even need that. Second x squared. So on the left-hand side, about halfway down. Now, in a newer calculator, it just like draws the square root, starts blinking inside. And I can just start typing whatever I want. For me, I need to type x plus 8. If you have an older calculator and it just like opens up a set of parentheses, you can type whatever you want, and when you're done, you put. Like as I kept typing, it just kept like extending the square root. It got bigger and bigger and bigger. But I've got something outside that I need to get part of this equation. What should I press to get myself out of the square root? Just like we got ourselves out of the exponent. That's the right arrow. It's actually blinking. You don't even see like a right arrow blinking if you're in the calculator. What is it, minus 4? Now, I like shifted my table around as I went looking for more points after the 0. So when I go back to table set, it's not set to start at negative 10. Again, I got to do that. So the second window, I'm down at negative 5. I got to change that to negative 10. My delta table didn't change though. So I'm going to here, table set, going table start. You can start with negative 10, delta table, and then I can actually click second graph and take it. Look at those first two y values. When you click on table, when you click second graph, you started your table at negative 10. What's the y value say for negative 10 and for negative 9? Why? Why am I not actually getting a number back? For a number like negative 10 going in for x or negative 9. What is negative 10 under that square root? Negative 10 plus 8 is negative 2. I can't take the square root of a negative number. That's imaginary. We're not going to get an actual number back until the calculator pops out an error, which means that part of the graph is empty, completely empty. You keep drawing these graphs with arrows on both ends. Square roots have a beginning. And there's going to be a space where this function doesn't even exist. But I do like negative 8, negative 4. I do like negative 7, negative 2. But I tell you what I don't like, negative 6 and negative 5. I don't want to try to plot those weird long decimals. And you see how it says like negative 1.172 and then it stops? If you actually arrow yourself into that box and look at the bottom, that number goes on way past the 2. That's that kind of square root that we know is no good. That's the square root of 2. That's part of a square root of 2 that's kind of stuck under there. So I'm not going to even write down negative 6, comma, whatever, negative 5, comma, whatever. But I do like negative 4. But negative 3, no. 2, no. Negative 1, no. 0, no. Ooh, 1, comma, 2. I had to scroll down to see it, so I'm pressing the down arrow one time. 2, 3, 4, 5, 6, 7, no. Ooh. Yeah. And 9 is no good, 10 is no good, and I'm out of space in my graph, so I'm out of space connected. But what we have to remember is we just came like negative 9, negative 10, and if you can scroll up, you'll just see more errors. You cannot take the square root. That's why table's done. Let's make ourselves a table for the inverse. What am I missing? That's my function. How do I know this is the inverse? Negative 1, negative 1. Super easy, make the switch. All your x's are now your y's. All your y's are now your x's. And if I'm going to graph this thing on paper, I am absolutely going to press the graph button and take a look and see what it is. You can see that that graph has a beginning. I don't know if you can see it right there, but if you press graph, there's a point that negative 8, negative 4, this one right here, that's the start of my graph. There's nothing to the left of that. I am not going to extend that past that. Negative 7, negative 2. Negative 4, 0. 1, 2. And 8. Now, so you can see on that graph that there's no left edge, right? It doesn't keep going, but that does keep going towards the right edge. So we'll definitely put an arrow out here on the right-hand side, because those numbers keep going. I'm just going to connect them smoothly. This is not a straight edge kind of thing. The only thing we're going to connect with a straight line is going to be a straight line. So I'll send it out with a little arrow on the edge. If that's how my function looks, my inverse is going to be pretty similar. It's going to have a beginning, but not have an end. Negative 8. Bottom here for x is negative 4. Plot my points. Connect them nice and smooth. Not worrying about being perfect, just doing the best I can. 4, 8. Found my beginning. There is no end. I'll throw an arrow on the edge. And my y equals x line down the middle. Top right, bottom left. lines. Finish it up. Find the intersection. You know what to do. Switch your X and Y. Start. Oh, I write this down every time. You don't have to write it anytime. This is reminds me what I need to do. And you don't have to do it that way, but man, it's the easiest way by far. If you like squared everything right now, you would have yourself a disgusting problem. If you add 4, and you take your addition subtraction first, and then divide by 2, right? If you do our addition subtraction first, gone. Bring it down. Oh, x plus 4 is my left hand side. Okay, cool. X plus 4. Right side gets simpler, left side gets more complicated, and step of solving done. Now we didn't have a number sitting out front of these parentheses, right? In front of that grouping symbol, so there wasn't any multiplication or division to do. But we do have a number sitting out in front of a grouping symbol here. That's where this grouping. And now I am good to divide it. Whatever your left side is, that's your left side. Try and get y by itself. Can we subtract 8 right now? No, we have that square root. Good, Stone. The opposite of squaring something is a square root. The opposite of a square root must be right? They're kind of one and the same as opposites of one another. So be careful. A lot of people would just like throw a square root on the left. No. I got to do the opposite of that. I need to take this, the entire right side, and square it. Of course, I'll do the same. So if you have a root, then you better get an exponent. If you have an exponent, you better get a root. You have to have both if you want to. And again, don't even try to square this. It is messier than you realize. Just write it. X plus 4 over 2, all in the parentheses, all that squared. Square the square root for them. Exponent is done. Now we're inside the square root, right? We're inside with our y plus 8. Now I have to go back to the beginning and try to take care of that plus 8. We'll go minus 8. Exactly as you would read this out loud is a great way to write it down. Come over here, space. X plus 4 divided by 2 squared minus 8. That's 4. I'm going to make the switch, put the y on the left. Everything else on the right, you do not have to, but it is the version is good. Make sure you put that little negative one up the top. Here is probably, I would guess, the work that we'll do over the next 2 or 3 days. That'll be due Friday. Now, this is, we just did 8 on there, 8 problems. This is only 6. Here's actually 1. I figured this would kind of cover it, because it's got, hold on. So what we've been working on is 3.1. This is 2.2. Now we've really got a pretty good handle on it. Now look, I actually included instructions. Create a table for the function, table for the inverse, graph both, and the line of symmetry, find the equation of the inverse algebraically. We've got a line, a quadratic, a cube root, a square root, a funky line with a 2/5, and then a 2/3/4. We'll have plenty of time during class, whether you're home or remote, to actually work on it. But I'll tell you what, since we only have one more actual in-class time, don't think you can get this all done on your one more in-class day. Unless you can do 6 problems in 45 minutes. And maybe you can, I don't know. But we've been averaging about 2 or 3 every class. And that's me taking my time and going super slow, making sure that it all makes sense. I mean, it's super slow, but like taking my time and making sure we understand how to do it. Maybe now you're like, oh, all right, I think I got it. Do this at your pace. It's due Friday. Save as much as you want for next class, sure. But know that just that is probably not going to be enough time to get the whole thing done. So you'll have to spend some time during your remote days, during class time. I'll dedicate it to you guys. And we'll work through it. I'm happy to do that. Like starting tomorrow, we'll do 1 and 2. Thursday, we'll do 3 and 4. And then 5 and 6 will just be up to you. Maybe I can do 1, 2, and 3 tomorrow. And then 4, 5, and 6 on Thursday. And then your Friday's done. We'll see. But you want to be present and working through it in class if you want to get it done. Again, this is not correctness. This is just classwork stuff. So get it done and get it done on time, and you'll get full credit. And because these are longer, both of these are worth 10 points instead of 5. So if your homework grade, if your classwork grade is suffering a little bit, here's a really good chance to kind of make up like 2 homeworks at once because it's worth 10 points instead of 5. And then next week, we'll do a quiz for correctness. A quiz for the effort and completion, and then something for correctness. I might call it a test, but it probably won't be out of 100 necessarily. It's not enough stuff, but who knows? On your in-class days only. Okay, something like that. You guys sit in front of me, cohort B. I will probably give you next week's quiz on Thursday to take home so you have a printed copy in case you don't have a printer home. It's so much easier to do it on this piece of paper than trying to draw it out yourself. And then the same thing will happen on Tuesday. I will give you the stuff for Wednesday, Thursday, so that you can just get started on it. By then, hopefully these ideas are good. You feel really good about them, and you're all set. I'm going to go back and I'm going to recreate the answers for 5 and 6 for the 7th period since they missed. So this is about to go away. I hope you wrote it down. But we're good. I'm happy. 3.1 due today. So get done. Like if you haven't been doing this, then you are behind. I have done every single question now in class. So if you haven't done that, you're going to have to go back, watch some videos, and you can fast forward to the good stuff. I'm cool with that. They're all sitting on campus for these last couple days. But it is due tonight, so you want to get that done. And then 3.2, the thing you just got from me, that's not due until Friday. Any questions about any of this stuff while we have like 5 minutes of downtime? Yeah.
I just need a little extra help when it comes to the solving it algebraically.
Okay. Go ahead, ask away.
So like with this one, I really don't. I couldn't
Follow along as well. Okay. So the idea is, and I think it sometimes helps when I have different colors. Like, so you start with the equation, which x and y, and then because my right side is where that y is that I'm trying to solve for, I have to start moving everything away. That's kind of my mindset. It's like, all right, I've got this y stuck over here on the right. I gotta start sliding it over. And the only and best way to do that is to start undoing what's happening by doing the opposite. Like, oh, I have a -4. Let me do a +4 because those are opposites of each other, and they're kind of like the simplest way to start. Right? Addition subtraction is the simplest operation. Then multiplication division, a little trickier. Then exponents. And so like I write my switch X and Y version, and then I do one step from this level of order of operation. Whatever I have, I do the opposite. Oh, I had a -4, cool, I'll do a +4. Those will always cancel. What that does is it takes that and kind of moves it over to the left side. And so it used to just be X, well now it's X +4. And so what you do is you read the left side out loud, or like in your head, in your inner conscience, your inner monologue, right? You say it out loud, or you say it in your head, but you write it down left to right instead of right. X +4. Okay, cool. X +4. That's right. And so I go from like an equation, a step, equation, and say, okay, that level, go. I'm happy. Move up one level and check to see if you have any of this happening. Like, is there on the right side, because that's where Y is there anything happening on that right side with multiplication? Well, yeah, that 2 and this square root, they don't have a symbol between them, just like 2x, there's no symbol between them, they're connected by multiplication right there. When I have multiplication, I better do the opposite. What's the opposite of multiplication? Division. So I do a step, right? Equation, step. Equation, step. And by dividing by 2 on this right side, away they go. Just like -4 +4, those cancel out. Cool so far?
Got it.
But whatever I do to the right, I got to do the left. And so I put a little like dividing by 2 on the left as well, but like there's the left side. X +4 squared. I'm sorry, X plus 4 divided by 2. Like that right there, I kind of combine like what was the left side with my step of work, whatever I did, and I write it over here on the left. And once I divide it by 2 on both sides, these 2's are gone. The only thing I have left is the square root. Okay. Done. Done. Up again, we'll go another level up. Exponents and roots are opposites of each other. So I look at what I have and I say, okay, equation, step, equation, step, equation. I'm ready for my next step. So what's my next step going to be? Well, it's got to be getting rid of an exponent if I had one, or getting rid of a root if I have one. We have a root. I got to get rid of it. So I have to do a step to get rid of it. Like I had to do a step to get rid of the 4, a step to get rid of the 2. Now I have to do a step to get rid of the square root.
You have to square it, right? And
Square the right,
so,
square the left.
so does that work with the square roots? If there's if it's squared, then you square root it?
Exactly.
Okay.
Those are always opposite of each other. And the square and the square root cancel each other out. X plus, or Y plus 8 is all I have left.
Okay.
So then what about my right or my left side? Well, it's whatever I have, right? See how those are the same? Right? This and that were the same. This and that were the same. These kind of like work their way down as you go. And once I get there, the only thing I have left is that +8. So I do a little -8, -8. Instead of writing it vertically, I just write it horizontally because it's plus.
Okay.
And then I'm done because we got the y.
All right. Thank you.
There you go. Yeah.
Oh, Rosie, I also had a quick question.
Sure.
What about the some of those assignments?
Yeah.
You know what the due date is for some of those missing assignments?
Like from last unit, from quadratic stuff?
I'm just talking like missing assignments before the end of the quarter. Like, do you have
Oh,
a set due date?
well, I mean, like a quarter progress rate is going to go in, but it's just a progress.
Okay.
The sooner you get them done, the more points you're going to get.
Okay.
That's really all it's kind of is.
Is there like a list that need to get done, or?
If you look on Infinite Campus, anything that's marked as missing is missing.
Okay, you'll still accept that?
Anything's better than a 0, absolutely.
Okay.
And I will give you something.
like someone has a shoes off.
I don't smell it. So,
Has anyone ever called you Mr. Rosie or
Liam Rogers called me.
I just thought that you
Yeah.
Sure.
You know, our work from yesterday, in case you missed it.
Hey, Rosie.
Hey,
I'm here today.
that makes me so
I
happy.
didn't get to see you last week.
I know, what, that made me so sad.
Well, I didn't come in one day and the other day,
Uh-huh,
then the other day, it's snow day,
uh-huh,
and then the class before I was late.
uh-huh,
It's terrible events, so I
uh-huh.
have to over and over.
They're in the yellow desk where the thing. Where the speaker's sitting on, or any of the ones on the phone. Usually they go. So I would sit on the one that has the little portable speaker. But it's good to have you, man. Welcome back. Did it say 6 on that desk?
It does, yes.
Perfect, that's the one. It has a big red, like a box wrap red attic and some high.
Yeah.
So now I'm happy. Hey, look, see if like that.
Oh my
That's the
God.
answer.
Oh my God.
Alright, let me get hooked up here to the weeks. I think I'm probably recording from last time.